6.2 is the division of polynomials, dividing by monomials, doing long division, doing synthetic division. We'll cover all three briefly. This is a monomial here on the bottom of this polynomial. That means there's only one term. There's no addition or subtraction. When I have a monomial, I'm going to take everything on top and divide it by what's on the bottom individually. Each thing gets divided by that negative 4x squared on the bottom. You can really think about it like you're doing this, where I took each term, 12x to the 7th, and I did its own division problem each time, and I'll do it 1, 2, 3, 4, 5 times. I really don't recommend you write it out that way. You sure can, but I think it's a lot of work. I think the way you should go about these problems is just do 12x to the 7th divided by negative 4x squared. Well, 12 divided by negative 4 is negative 3. X to the 7th divided by x squared is x to the 5th. And then I'm going to do negative 8 divided by negative 4. Negative 8 divided by negative 4 is positive 2. X to the 6th divided by x squared is x to the 4th. Positive 6 divided by negative 4 reduces to negative 3 over 2. 6 over 4 is 3 over 2. And x to the 4th divided by x squared is x squared. 5 and 4 can't reduce at all, so I'm going to just keep this negative 5 over 4x, because x to the 3rd over x squared is just x. Finally, this is the one that confuses people a lot. Negative 4x squared divided by negative 4x squared is just positive 1. It's not 0. They don't kill each other entirely. Something divided by itself, that's what this is, something divided by itself is just 1. So that's the simplification when you're dividing by a monomial. It's fairly straightforward. I'm going to review how to do long division really quick, because I think long division is something you haven't done in a long time and something you've forgotten, and you might actually learn something new here you haven't learned before about long division. When I'm doing 12,870 into 14, well, really I'm doing 14 into 12,870. The number on top goes inside, the number on the bottom goes outside. I'm doing this division. I want to see how many times 14 can go into 1. 14 can't go into 1. In fact, 14 can't go into 12. So I do 14 into 128. 14 goes into 128. Let's see, 10 times 14 is 140. So that's too big, obviously. So I'm going to try 9 times 14. 9 times 14. 9 times 4 is 36. So 6 goes there. And oops, excuse me. I'm going to try 9. So I put a 9 here. Since I'm going into 128, the number I'm plugging in goes into the last digit. 9 times 14 is 36, so 6 goes there and 3 goes there. 9 times 1 is 9, plus 3 is 12. And I subtract 128 minus 126 is 2. 2 is smaller than 14, and that's a good thing. So I drop down this 7, I get 27. 14 goes into 27 once. 1 times 14 is 14. Subtract again. 14 goes into 130. 9 times again. So I know that 9 times 14 is 126. I've already done that. Negative 4. Now at this point, we could do a point 0 and drop down another 0. Here I dropped down this 0 before. I could do a point 0 and drop down another 0 here and start doing a decimal and put a decimal up here if I wanted to. But I'm going to talk about remainders now. We haven't actually done remainders in a long time. We've probably done remainders since grade school. But instead of getting a decimal, I could take this last number that I can put in that box, and my remainder is this number 4, divided by this number 14. 4/14, so my answer is really 919 with a remainder of 2/7, which is the same as really 919 and 2/7. Whatever decimal expansion I would have got out here would have been the decimal expansion of 2/7. When I talk about long division with regular numbers, because we're going to do long division with polynomials. And it follows almost the exact same process. I'm going to try and compare and do this multiplying, subtracting, dividing thing. We do long division with polynomials. The number on the bottom goes out in front. An important thing to understand is with this number with this term on the bottom, I have to account for every power of x. So I have 2x squared plus 0x to the first plus 4. I have to account for the fact that there is no x term, and I want to have that. That's actually not critically important on the outside, but if that were to happen here on the inside, it would make a very, very big difference. So always try and have all those x powers accounted for. And here on the outside, I have 2x to the fourth, plus 6x to the third, plus 2x squared, plus 12x minus 8. Okay, here we go. I'm going to look at the first term here and the first term here. And my question is really 2x squared times what equals 2x to the fourth? 2x squared times what equals 2x to the fourth? Just like how here, I really did 14 times what is close to 128. Well here, 2x to the second times x squared equals 2x to the fourth. 2x squared times x squared is 2x to the fourth. So this answer of x squared is going to go here in the x squared column. I match these things up by the powers. And now that I've found my first multiplier, I'm going to do x squared times 2x squared. And x squared times 2x squared is 2x to the fourth. I do x squared times 0x, and x squared times 0x is 0x to the third, which is just 0, I know, but it's nice to have that placeholder here. And then x squared times 4 is 4x squared. Now, just like how in this problem we always did subtraction, here we're going to do subtraction. And this subtraction throws a lot of people off because I'm subtracting everything. The whole entire stuff is getting subtracted. So what I actually do is I take every single sign and I switch it. In this case, they're all positive, and all the pluses are going to become minuses. I subtract this, subtract this, subtract this. 2x squared, 2x to the fourth minus 2x to the fourth is 0. 6x to the third minus 0x to the third is 6x to the third. 2x squared minus 4x squared is negative 2x squared. Then, just like I did over here, where I dropped down a power, dropped down the next term, here I drop down the next term and I get plus 12x. Okay, we've just done one round of long division. We're going to do the whole thing again. I'm going to see how many times does 2x squared, the first term, go into this first term, 6x to the third. I only compare the first terms. And in this case, the answer is 3x. 3x. 3x times 2x squared is 6x to the third. 3x times 2x squared is 6x to the third. So my answer here is going to be 3x. So I do 3x times 2x squared, which is 6x to the third. 3x times 0x is 0x squared. And 3x times 4 is 12x. I subtract these from each other, so that becomes a minus, that becomes a minus, that becomes a minus, because I'm subtracting all of these. And I get that negative 2x squared minus 8. Okay, now the question is 2x squared goes into negative 2x squared how many times? 2x squared goes into negative 2x squared negative 1 times, so put a negative 1 here. I multiply, I dropped down the negative 8 already. That negative 8 came down from there. So it was a 0x here, excuse me, so I kind of went backwards there. Negative 1 times 2x squared is negative 2x squared. Negative 1 times 0x is 0x. Negative 1 times 4 is negative 4. And then I'm subtracting these, so all of these signs switch, and I get negative 4 here. Well, 2x squared can't go in to negative 4. That's not possible. So just like before, I'm going to grab a remainder. Now that I can't divide anymore, this is my remainder, so I also have a minus 4 over 2x squared plus 4. Should be right like this. The negative 4 goes on top, and the 2x squared plus 4 goes on the bottom. I can reduce that a little bit, so my actual answer is going to be x squared plus 3x minus 1 minus, all of these can be divided by 2. So I'm going to do 2 over x squared plus 2. Put that negative out in front. If there was a negative here, I pulled it out in front because why not? That is long division. of polynomials. It takes some work, but it's really just multiply, add, subtract over and over and over. The last thing we'll do is synthetic division. You're going to like this one much better. The thing about synthetic division is that it only works with binomials that are linear, meaning this can't have any power and there can't be more than 2 terms. It only works on linear binomials. But the thing is, the key is, I take whatever makes the denominator equal 0. In this case, -3. I take -3 and I put it in this little corner box thing. And out to the side, I'm going to write all of these coefficients. I have a 2 for my x to the 4th. I have a 5 for x to the 3rd. I have a 0 for x squared. Please remember, you've got to keep all of these powers accounted for. 0x squared plus 5x minus 14. I just write out all the coefficients and I make this little chart. And this is a synthetic division process. It's much faster than long division. This number 2, it just drops down. The first thing I do is -3 times 2, and -3 times 2 is -6, so I write that over here. And I'm going to add these 2 columns. 5 plus -6 is -1. I do -3 times -1, -3 times -1 is 3. I add that column. 0 plus 3 is 3. -3 times 3 is -9. I add again. 5 plus -9 is -4. -3 times -4 is 12. -14 plus 12 is -2. This last number goes in a box to my remainder again. The beauty of this is whatever my biggest power here was, these all drop down. These are my new coefficients. So my solution is going to be my quotient, really, 2x to the 3rd minus x squared plus 3x minus 4, and then plus a -2 over x plus 3. That's my remainder. That is synthetic division. It does the long division process much faster, but again, it only works for a linear binomial. Had this been some polynomial over like this, then in the box, I would have put a -2/3, because -2/3 is what makes the bottom equal 0. I subtract 2 from both sides. 3x equals -2. Divide by 3, x equals -2/3. Thank you all.